So in the last couple of lessons for chapter 5, we've learned all of these properties of all of our different types of quadrilaterals, right? We practice using them and writing proofs using them and all of that. So today what we're going to do is we're going to start flipping it around, right? Before we said, if I know I have a quadrilateral that is this type, what does that tell me? And now we're going to start flipping it around and saying, well, how do I prove that my quadrilateral is one of those types, right? So today we're only going to focus on parallelograms because, again, like we've said so many times, the parallelogram is the one that we use the most often. It has the most properties and, the most things that kind of fit inside of it. So we're going to just focus completely today on how do I prove that this four-sided figure is a parallelogram. We're going to have multiple different methods and we're going to practice using them. Tomorrow then, in our next lesson, we're going to learn how do I prove all the other types. So get ready, but get the idea of what we're doing today. So here we go. This is all of our ways to prove that a quadrilateral is a parallelogram. So you'll scroll down so you can see. We have 1, 2, 3, 4, 5 ways. So if I were you, I would make sure that I would have a place to write these good if-then forms, but I would also draw the picture. And I'm going to mark this picture up as we go because sometimes just having that picture will trigger a lot in your brain as you go. So pause the video whenever you need to make sure that you keep up and write down both the if-then form and draw the picture. So our first way to prove that a quadrilateral, so any four-sided figure, if the way to prove that it is a parallelogram is the first way is if both pairs of opposite sides are parallel. If both pairs of opposite sides are parallel, then it is a parallelogram. Now, if we think about it, if I'm going to prove that this four-sided figure is a parallelogram and can't be anything else, then we kind of have to think of, okay, well, what other shapes have this property? Because if another shape has that property, then it's not enough to prove that it's a parallelogram because it could be one of those others. So if I just say, okay, what if I only proved one pair of opposite sides are parallel? What other shape could it possibly be? It could be a trapezoid, right? And a trapezoid is not a parallelogram if you think of your family tree. They're not connected. So only proving one pair of opposite sides parallel, that's not enough because it could be a trapezoid. So I do have to prove both pairs of opposite sides are parallel. So I'm marking my picture there. But there aren't any other shapes that have both pairs of opposite sides parallel. You might argue with me, but Ms. Crivo, rectangles have both pairs of opposite sides parallel. True, but a rectangle is a parallelogram, so it's fine, right? So does a square, so does a rhombus, but if you think of your family tree, all of those shapes are underneath parallelogram. It's still a parallelogram, it's just a more special type. So what I'm trying to rule out are things that are not in the same branch. So I have to make sure that a kite doesn't have this, and a trapezoid doesn't have this, and an isosceles trapezoid doesn't have this, right? Those are the things that I can use to prove that I have a parallelogram. So this was one of the properties of a parallelogram, and because it's specific only to a parallelogram, as long as I prove both pairs of opposite sides parallel, I know that it's a parallelogram. All right, so you're kind of getting the idea. So the next method is to prove both pairs of opposite sides are congruent. So again, if you only proved one pair of opposite sides congruent, that could be an isosceles trapezoid, right? An isosceles trapezoid has one pair of opposite sides congruent. So I do need to, in fact, prove both pairs of opposite sides congruent. And again, if you think of all the other shapes that have that, they're all underneath that parallelogram in the parallelogram branch, right? So they're still parallelograms, they're just more special parallelograms. So it's cool to use it to prove it's a parallelogram. All right, the third one, if both pairs of opposite angles of the quad are congruent. So opposite angles, 1 and 2. Again, if I only proved one pair, that could be a kite. Remember, a kite has one pair of opposite angles congruent. So proving only one isn't enough. I have to prove both in order to prove that it's a parallelogram and not a kite. All right. The next one says, if the diagonals bisect each other. So here's my two diagonals, right? this says bisect each other, which means both diagonals are bisected. So I do have to prove that both of them are bisected, because if I only prove that one of them is bisected, that again could be a kite. So I need to prove that both diagonals are bisected in order to know that it's a parallelogram. But then the only things that have the diagonals bisected, both of them are in that parallelogram tree. So those were all actual properties of a parallelogram. You could pull those right off of our list, right? And those are properties that are specific to parallelograms only. And so those are ways that I could prove that I have a parallelogram. Now the last one is an additional one. This one isn't specifically a property that's listed, kind of, but not really. But if we're thinking about ways that we could narrow down that it's not a kite and that it's not a trapezoid, if I have one pair of opposite sides, then I know that that one pair of opposite sides is parallel. Ooh, it could be a trapezoid, right? But if I know that that same pair of opposite sides is also congruent, when I have a trapezoid, if I have a pair of congruent sides, it has to be the non-parallel sides, right? In a trapezoid, those two parallel sides are not congruent. It needs to be, the bases are parallel and the legs are congruent for it to be an isosceles trapezoid. So if you can prove that that same pair of opposite sides are both parallel and congruent, then you know it's a parallelogram, because it can't be a kite. Opposite sides are not congruent in a kite, and it can't be a trapezoid or an isosceles trapezoid when it's the same pair that are parallel and congruent. So that's kind of a bonus method that we actually use quite a bit. So those are the 5 different ways that we could prove that we have a parallelogram if all I know is I have 4 sides, a 4-sided figure. The good news is you've got a lot of options, right? The tricky news is that you have to figure out which one you're going to use in each situation. And the best way to do that, practice. All right, so here's our first proof. I, again, would recommend write it all down, see if you can prove it. Pause the video, see how you can do, and then come back and watch again and see if you got it, okay? So first step here, first thing we know, ELFS is a parallelogram. And I could use the symbol here if I wanted. Parallelogram, there we go. All right, so I know that my big shape, maybe I'll use a different color. My big ELFS, this is a parallelogram. Okay. Step 2, angle ELV is congruent to angle OSF. ELV is this angle up here. OSF is this angle down here. All right, and I'm going to try and prove that LOVS, my little one, is a parallelogram. Okay. So I know the big one is a parallelogram, so I can use all of the properties of a parallelogram on the big shape. I'm proving the little one is. So I need to figure out, am I going to try and prove both pairs of opposite sides parallel? Am I going to try to prove both pairs of opposite sides congruent? Both pairs of opposite angles congruent, etc., right? Which one of these methods am I going to use here? Well, let's see. If I know that my big shape is a parallelogram, well, I know a lot then. I've got some congruent sides, right? I've got some congruent angles. So let's see what I can do here. Well, I know that if I have a big parallelogram, then I know that these pairs of opposite sides are congruent, right? So segment LE is congruent to segment FS. If a quad is a parallelogram, then opposite sides are congruent. Okay. Well, okay. And I could use that same reason to say that these sides are congruent, right? Step 4, LF is congruent to ES, same as 3. So I'm trying to kind of formulate a plan here. So if I could somehow prove that these little parts are congruent, then if I know the big parts are congruent, if I can prove the little parts, I could use subtraction property to get these guys to be congruent, and maybe I could work on both pairs of opposite sides congruent. Oh, and if I'm going to try and prove, maybe I could prove these two triangles on the corners, this guy and this guy. If I prove those guys are congruent, then I could get the other pair, OS and LV would be congruent, and I could get my both pairs of opposite sides congruent. All right, that's going to be my plan. So what do I need then? I've got an angle and a side in those two corner triangles. I need another angle. Oh, I've got it. So I know, because I have a parallelogram, that the opposite angles are congruent. So step 5, angle E is congruent to angle F if a quad is a parallelogram, then opposite angles are congruent. And now I have triangles congruent by angle, side, angle. Step 6, triangle LEV is congruent to triangle. Let's see, I started with the orange, so SFO. And that was angle, side, angle. And I got my first angles from step 2. Green marked sides is step 3. Purple angles is step 5. So 2, 3, and 5. All right, so now that I know that my triangles are congruent, then I know segment LV is congruent to segment OS by CPCTC. All right, here's my first pair of congruent sides, right? So I've got one pair of opposite sides congruent, but remember, I need to have both, because if I only prove one, it could be an isosceles trapezoid. Okay, so then I also wanted to prove those ones, right? Maybe I'll use, I also wanted to prove these parts congruent, so I could use the subtraction property. So step 8, OF is congruent to EV, and that's also CPCTC. So I got two pairs of sides from CPCTC, but those ones aren't in my parallelogram yet, so I have to do a little subtraction property, right? So step 9, LO is congruent to VS. Because I knew my big segments were congruent and I was subtracting these two that I just got from CPCTC, then I know that my other little pair of segments are congruent. So this was the subtraction property. The two congruent segment one, if you really care, but at this point we can just write subtraction property, right? All right, and now as you can see in my little yellow parallelogram there, I have both pairs of opposite sides are congruent. So step 10, LOVS is a parallelogram. If both pairs of opposite sides of a quad are congruent, then it is a parallelogram. And again, that was straight off of your list. That was this first one right up here. If both pairs of opposite sides are, oops, not parallel, sorry, it was the second one. If both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. So that was the one that we just used. All right, so again, that's kind of how you're making your plan, right? What do I have? Which one of those would be easy to get? So I've got one more to practice here using a different method this time, seeing if you can see a different one. So again, set it up, pause your video, see if you can do it, come back and check. First step says segment CY is congruent to segment RA. All right, step 2 says angle Y is congruent, there we go, to angle A. Angle Y and angle A. All right, step 3 says triangle CBY is isosceles with base BY. All right, triangle CBY is isosceles with base BY. Now, I am immediately going to write down step number 4. Whenever I see that I have a triangle that's isosceles, I know that I'm going to have to use my congruent sides somehow, right? So if my triangle CBY is isosceles, that's this triangle, right? Okay, and if BY is the base, then CY and CB must be congruent. So step 4 will say segment CY is congruent to segment CB if a triangle is isosceles, then the legs are congruent. Okay, so now I know that. Well, that's weird. Okay. I see that I have 3 segments marked congruent, but in 2 different colors. So let's just take a quick look here. What am I trying to prove? I'm trying to prove that CRAB is a parallelogram. Sorry about the phone ringing. Okay. Oh, so that would be the same. That would be a pair of opposite sides congruent once I show that those are congruent to each other, right? Remember, if I have 2 segments that are both congruent to the same segment, right, CY and CY, then they're congruent to each other. That's the transitive property. And now I can just write transitive property. So step 5, whoops, can't write with the highlighter. Here we go. CB is congruent to RA with the transitive property. And that would be the first one, the same segment one, right, if you cared, if you wanted to. So now I know that all 3 of these are congruent to each other, right? Okay, so I have 1 pair of opposite sides are congruent. I don't know a lot else about those. Well, you know, we talked about having this isosceles triangle. Whenever I have isosceles triangle, I can definitely get sides. But whenever I have that isosceles triangle, I always have that sides imply angles, right? So let's see. Sides imply angles would mean, that angle Y would be congruent to angle CBY. So step 6, angle Y is congruent to angle CBY. And that is sides imply angles, right? Well, there again, I see that I have 3 angles marked congruent. So that means that step 7, see how both of these are angle Y is congruent to angle A and angle Y is congruent to angle CBY. So A and CBY are both congruent to the same angle. So that must be angle A is congruent to angle CBY. And that again is the transitive property. If 2 angles are congruent to the same angle, then they're congruent to each other. So now I know that all of these guys are congruent to each other. But those aren't the opposite angles in my parallelogram. Wait, I already have this pair of sides that are parallel, or no, that are congruent, right? If I can prove the same pair of sides are parallel, then it would be a parallelogram. Do you see those 2 sides, right? The 2 that are congruent, if those were my parallel lines and I had a transversal, this would be the transversal. Sorry, that couldn't really. Angle CBY and angle A, those are corresponding angles, right? So step 8, segment CB is parallel to segment RA if corresponding angles are congruent, then the lines are parallel. And so now I have the same pair of sides that are both congruent and parallel. I have a parallelogram. So step 9, CRAB is a parallelogram if 1 pair of opposite sides are both parallel and congruent, then, 1 pair of opposite sides, I should say, of a quad are both parallel and congruent, then it is a parallelogram. Sorry, missed those words in there. All right, so that was using this bottom one, right, on that one. One pair of opposite sides, both parallel and congruent, then it's a parallelogram. All right, so we practice here, like I said, it just takes practice knowing which one of those to do, so that's going to be your job today.